Hello, welcome to the session. Today we are going to talk about DevSecOps. In this session, we will take a brief look at some of the prevalent software development methodologies like Waterfall and Scrum, and then use them to comprehend the DevSecOps process. In this slide, we are going to take a look at the Waterfall model. This is one of the earliest and widely used software development methodologies. As you can see here, in a waterfall model, the development takes place in a series of phases. So the phases are requirement analysis, design, development, testing, and maintenance. And the teams who work in each of these phases are analysts, architects, developers, testers, and support engineers. In the first phase, we have the requirement gathering and analysis. The business analysts will work with the users of the software and identify the needs and wants for the product. Then they will use that to come up with the system and software requirements. And once this phase is complete, there is a BRD, a business requirements document, or commonly called the scope document, which is made available. In the next phase, the architects will use the scope BRD document to come up with a high-level design of the system. And once the design document is available, we enter the next stage. In this development stage, developers will write the code and develop the software. And once development is complete, the code package is handed over to the testers. And they start their testing. In this phase, the testers will determine if the software is working as expected. They perform the verification and validation of the software. And once testing is complete, the software is deployed into production. And this is the maintenance phase, where support engineers handle the software operations. So where do we use this model? When is it effective to even use this model? As illustrated by the image here, this model is quite effective when we know the requirements completely. For example, if we are constructing a house, we generally don't build it room by room. We will first start with the requirements and then come up with the design for the house and then start the construction. So similarly, waterfall model is used when the requirements are clear, concise, and do not change. Okay, so how long does a waterfall project take? It typically takes from start to finish several months. In some cases, it might even take years to finish. And what about application security? In most cases, it is just an afterthought. There are no security considerations during any of the development phases. In this slide, we are going to take a look at agile development practices. It is a set of software development methods that is based on iterative and incremental development. In this model, requirements are evolving. As shown in this picture, you start with the requirement to draw a lady and then decide on the setting, which is pastoral, and then the colors, and finally end up with the Mona Lisa picture. You do not have the end picture in mind at the start of the process. Your needs and your requirements are evolving at each stage. Next, what are the different phases or stages? Like in waterfall, you still need your requirements and then design before you can code and test. The difference though is these steps are continuous and performed in each iteration. You do not know all the requirements in the beginning, so you plan with few well-known requirements. You design, code and test in that iteration, release whatever was developed and get the feedback. And then you repeat these steps in each iteration. So in this model, how is the team composition? Since each iteration has the different phases, you have a cross-functional team. The team comprises a product owner who is responsible for giving requirements, a scrum master who manages the development process, and then you have analysts, architects, developers, and testers in the team. And what's the typical duration of each iteration? This is typically in weeks. So the feedback loop is reduced from months to weeks. And what about software security? Well, this is still a question mark. It is still an afterthought. In this slide, we are going to talk about one of the widely adopted Agile framework methodologies, which is Scrum. As you can see from the slide, the product owner maintains a list of requirements, some of them well defined and some of them are just ideas or wishes. In the Scrum, each iteration is called a sprint, and this is typically 1 to 4 weeks. At the start of the sprint, the team meets and decides on the priority requirements from the product backlog and moves that to the sprint backlog. These are the items the team will work in that particular sprint. Then they design, code, and test the requirements in the backlog, the sprint backlog, and release the code for user acceptance. The team meets daily to discuss the progress in the sprint, and this is called the daily stand-up. Once the deliverables are ready, the team does a demo to the product owner and other stakeholders. And then when the sprint is complete, they do a retrospective on what went well and did not go well and note the lessons learned. So this is a typical process flow in Scrum process. In this slide, we are going to talk about the next stage of evolution, DevOps. In DevOps, we combine software development and IT operations. We do this to reduce time between development and deployment. In other words, DevOps reduces the time between committing a change and deploying that change in production. So in Agile, we seek to address the gap between business and developers. In DevOps, we seek to address the gap between developers and the IT operations and infrastructure teams. So in essence, Agile and DevOps are not competing models, rather they are complementing models. DevOps picks up where Agile stops. DevOps is not just combining Dev and Ops team. It is a set of processes and practices that have to be adopted throughout the entire delivery pipeline. DevOps is not just about using few tools like Jenkins. It relies on different set of tools called tool chain at every stage of delivery. So what are the stages in a DevOps model? As you can see here, the blue ones are similar to what we saw in Agile or Scrum. It involves planning, coding, and testing. Along with that, it has stages that include release management, deployment, operations, and monitoring. So now, what is the composition of a DevOps team? So along with the Scrum team, which includes analysts, developers, and testers, a DevOps team should also include people from the platform team, the backend team, the infrastructure and operations teams. So how long is the cycle in DevOps? Well, it could be in days or even in minutes if that is what is required. So from months, we have evolved to delivering in minutes. And finally, what about application security? Well, it still doesn't figure into the consideration. So now, let us start discussing the topic for this session, DevSecOps. Finally, instead of being an afterthought, security is right in the middle of all changes. It is now an integral part of the development cycle. In current day and age, where security is not limited to antivirus softwares and firewalls, software development, application development must include secure processes. It has to be secure software development. Like in this picture, if Agile and DevOps teams are churning out code in minutes and hours and days, then we cannot expect the security team to clean up the fallout of having insecure software. So in DevSecOps, we are striving to combine speed of delivery and secure code into one full-fledged and streamlined process. It aims to prove that we do not have to choose between agility or security. In fact, we can have both. So one of the important outcomes we expect from this is early detection of vulnerabilities and security flaws in the code. So does DevSecOps mean we have development team, operations team, and the security team? No, not necessarily. It means everyone in the team is responsible for security. The goal is not to introduce the security team into the mix. The goal is to incorporate security in every stage of software development. If we implement DevSecOps correctly, then with the inbuilt security measures, it is easy to have early and continuous security monitoring and risk management. And it involves integrating security into the CI/CD pipeline, bridging the traditional gap between security and development teams. As shown in the table here, DevSecOps is not a one-size-fits-all approach. It is a security mindset and a holistic approach. It is not another tool or method. It is rather a collection of tools and processes. It is not a way to adding security in the final deliverable. It adds security every step of the way. It is not about installing another vendor product. It is a community-driven effort. And it is not driven by perfection or a wish to put a tick mark in a checklist. It is driven by the need for continuous learning and experiments. In this slide, let us discuss the tools and processes that we can incorporate in the DevOps process to make it DevSecOps. We are going to use the same stage we saw earlier in the DevOps slide. So the first stage here is the planning stage. This is where the requirements are decided. So in this phase, to include the security aspects, we should be performing threat modeling and an architecture risk analysis. Threat modeling is a process by which potential threats and vulnerabilities are identified and any possible mitigations in place are documented. There are several methods and tools available to perform threat modeling. One of the widely used tools is Microsoft Stride model. Architecture risk analysis is a risk management process that identifies the flaws in software architecture and determines the risk from these flaws. So in the next stage, which is coding, we can use processes like code reviews and tools like IDE security plugins. IDE is Integrated Development Environment. The IDE security plugins are like spell checkers. They check for security flaws as and when coders write their code. These plugins help to find and fix common security issues before any code changes are committed into the repository. There are several security plugins available for the various IDEs. So once the code is ready, what do we do next? We try to build the code package. As part of the build process, while ensuring code is compilable and buildable, we need to have basic automated testing, and it should include static security code analysis tools. We just call them static application security testing tools, or in short, static AST tools. These tools check for common vulnerabilities like SQL injection, cross-site scripting, and other OWASP top 10 vulnerabilities. The first three steps we have discussed so far, threat models, IDE plugins, and SAST tools, these are deployed and performed in the development environment. So now we have a build ready, and then we also move into the testing environment. In this phase, along with functional test, performance test, regression test, we should also include security test. The best approach is to automate as much of testing as possible, and that includes security testing. Some of the widely used tools are advanced SAST tools, dynamic AST tools, and fuzzy testing tools. Static AST and dynamic AST for easy comparison are like white box and black box testing. Static AST is like white box where the code is examined for security flaws. Whereas DAST is like black box which is performed while executing the application. So now the code is tested, it is now ready to be deployed in production. So as part of the release phase, we need to have processes and tools for change management, release approvals, and release automation. The security approvals should definitely be a part of the release approval. The change management process should have steps to roll back any changes if a need arises and have a resiliency plan in place. So now we have all the approvals, we are ready to deploy the changes in production. So what next? What do we do here? In code analysis phase, we have performed static code analysis. In testing phase, we had static AST and dynamic AST tools. So in this phase, before deployment, we have to do a vulnerability assessment. In this step, we are not just looking for code issues or runtime issues. In this stage, we are evaluating the environment, network, configuration, and connectivity to identify any possible vulnerabilities or exploits and then determine the risk. Once the risk is determined to be within acceptable range, then the changes are deployed into production. Again, there are numerous tools out there to perform VA testing. Pick one that matches your organization needs. So, okay, the changes are in production, the changes are operational. What next? What do we have to do? We need to do continuous threat monitoring. We should have tools that help in gathering new threat intelligence and help with reconnaissance. So by now, we know the issues identified in the VA, our vulnerability assessment. We also know the emerging threats. Next, we need to put in place a process or tools that monitor how quickly and effectively issues are identified, remediated, fixed, or patched. This stage should also include tools to respond to any security incidents. Once we have all these processes that we have discussed so far, the last piece of the puzzle is how do we measure the effectiveness? We need to have metrics and reporting. We should have tools that analyze all the info and come up with meaningful insights that can be fed back into the planning phase for the next cycle. We hope this session was useful for you in understanding the DevSecOps fundamentals. Thanks for spending your valuable time with us today. Until we meet you again in another informative session, thank you.